All right, so now we're going to move on to visualization. So this is technically section 6. All right, so I kind of want to introduce like why we do visualization. I think it's an important aspect of it. I'm going to focus mostly on that to say like what we do visualization for and why we do it, because this will help you understand like why you're going to do the things you do, right? So visualization. So first thing is basically, does anyone know How I Met Your Mother? Like I know the show's not on anymore, but I love that show. Like I used to watch that show like literally like on loop, like with my college roommates. It was kind of ridiculous, but like there's a little clip in there which is like I'm like, this is the perfect data science clip. Basically, one of the characters, Marshall, really likes charts, and he basically makes a pie chart of all his favorite bars. And then he also makes a bar chart of all his favorite pies. And I'm just like, oh, that's so great. Like, but anyway, great little clip if you haven't seen it. But visualization, basically, the whole point of it is that we're trying to express numerical values in visual form, right? It's basically similar in the same sense that we have like statistics. We want to, like summary statistics, your summary statistics aren't going to tell you everything about your data. Like the true nature of your data are all the individual values. But like Jessica showed, like, doing dot round, that's going to take like, if you don't have a dot round, you're seeing all these extra decimal points. Like, look, I only need to see like the first 2. Like, it's not technically the full truth of the data, but I get the idea. And that's kind of what visualizations are doing. So visualization, basically, their whole goal is to tell us like a story or even a narrative. And it depends exactly what, like I will say is that it's telling a story, but it depends who you're talking to. So it really, like, you should think about when you're making your visualization is like, is this visualization for, let's say, your stakeholders, the people who are going to be making decisions who aren't data scientists? Are they other data scientists? Are they other analysts? Like, what is your visualization for? Your visualization could even be for yourself. These are called exploratory visualizations. So whenever you're making a visualization and you're just kind of going through it, it's really think like, okay, who is this for? And making sure that it's telling a story. I call it like a narrative, basically saying, what is the thing that you want your viewer, your audience to focus on, okay? And you've heard this plenty of times, a picture's worth 1,000 words. Quickly looking at this part right here, what can you tell me about this visualization? Like knowing really nothing about it. You can even say like by colors, you don't even have to like read off the graph.
Like which areas of the brain are activated when finding visual patterns?
Yeah, that's what it actually is about, right? So, and which is the most active, or at least, more, whatever that more is.
Frontal lobe.
Frontal lobe, which is in blue, right? It's easy, right? Anyone can do it, right? And you can see very quickly, oh, frontal lobe is a huge amount, right? Like compared to this orange, this green, this red. Look, I'm not even looking at these like key right here. But if I gave you this, like this gives you a huge amount of information versus me just giving you a number and stuff like that. And you're like, okay, yeah, if you gave me the exact numbers, I probably could figure it out. But imagine having many, many data points and then trying to give you just like, oh, like imagine just a spreadsheet of information. Like that's not going to be super useful to someone, right? There's at least very quickly looking at it. So visualizations allow us to very quickly look at this information and convey that information to other people. I like to say is that we're a visual species, is that we really take in a lot of information visually. This is where like people like always tell me, it's like, oh, I'm a visual learner. I'm like, I think everyone's a visual learner. Well, maybe I'm wrong because like obviously people are blind, but like I actually don't know. Anyway, I'm not going to go into that. So anyway, one thing too is that I love numbers. But numbers are awful to look at. And I'm going to prove it to you in case you're like doubting. It's like, no, numbers are amazing. I love looking at numbers. No one's ever challenged me on that, but in case you are, right? So I'm going to, first of all, import this data set. And you can see this data is 0.1 CSV. Ooh, exciting, right? So DF1 CSV. Tell me about this data. What's interesting about it? Does it speak to you? Can you feel it?
Y is sometimes smaller than X.
Y is sometimes smaller. Oh, that's good, right? It's a really interesting story, right? Yeah. So, okay, it's a little tough, right? Like, and there's only 10 numbers on here. Like, that's, like, look, this is the whole data set. That's not even a huge amount. So, like, okay, maybe do describe. Oh, okay, look at this. All right, there's 11 data points. Oh, you might have missed that if you didn't realize zeros there, right? Your mean is 9 in X, 7.5 for Y. Like, okay, and we got some standard deviations. Cool. We know everything we need about this data set, right? So is there anything in particular when you guys see this, something that stands out like, oh, like what this data could possibly represent, or like, what this, does anyone have this genius moment of just like, oh, I know what this data is? Probably not, right? They're just numbers, right? Like, so one thing I can do is go ahead and make a scatter plot, and you can see here, hey, look at that. So first of all, can someone tell me just something that's generally about this data set?
There's a linear relationship there.
Oh, that's beautiful. That just sent like flutters, right? Linear relationship, right? It's a line, right? And you can see it's not a perfect line, right? It's got some like, fuzziness to it. It's not like a complete perfect size, right? Now, if you're being honest with yourself, I don't know if I could like look at this directly without plotting it down to directly tell you, it's like, oh yes, there's a linear relationship here. It's just not super obvious by itself, right? You might be able to say this, like, I think, I forgot who said it, but saying like, oh, X is less than Y sometimes and stuff like that. But it's not super clear, right? It's also not super clear that's a linear relationship with some fuzz. And you can very quickly, like you look at that picture and you know immediately what's going on. All right, so I'm gonna put this visualization away. I'm actually gonna go ahead and delete this guy so we can see this. So I'm gonna show you another distribution, 0, 2. It's real exciting times here. So looking at this data set, oh, I actually realized I wanted to do something too. I'm gonna keep that there. Okay, so looking at this data set, anything interesting here? Yeah, you don't have to answer. I know it's nothing interesting, right? Like, if you look at it closely too, I'm gonna see if I can just very quickly just get rid of this guy. If you look at it closely, can anyone tell me like very quickly, like, are these data sets very different from each other?
X is the same.
Oh, X is the same, good. So there's definitely some similarity here. And you can probably look at Y, it's not
Similar.
exactly the same, right? But like, yeah, like what exactly that is. Yeah, so good. So one quick thing that we learned is df2.describe. We can actually see a little bit. So let's check this out. Hey, look, the mean is 9, 7.5. Okay, like standard deviation 3. We can see, hey, that looks really similar to here. If you look, I'm trying to keep on the same screen here. You can see, hey, it actually looks pretty similar, right? So maybe anyone can guess is like what, if I do this visualization, what this will end up looking like, considering that like the standard deviation is the same. It's like the same axis.
Relationship.
Linear relationship. Makes sense? Anyone got to disagree on that? That seems pretty clear, right? Like, oh, we saw linear relationship before. I'm going to plot this out. Not the same, right? Like, so you can see here very quickly, it's like, oh, that was very different. And that's the thing. It's like, looking at this visualization, you immediately know what is like the similarity between these two guys. So you can see here, like, we need something like numbers are great, right? But this by itself did not tell the whole story. Like maybe you could like stare at this long enough, but where you can see like just plotting it out can give you so much information just very quickly, right? And then you can explore deeper into it. Okay, so big thing about this is that this is 10 numbers, right? Imagine if you have many more numbers. So you can see here, my secret data set here. It's really exciting, right? So you can see here in my data set is that there is 142 points. I'm not going to ask you guys what you think this data set looks like because you guys know that I'm going to try to trick you guys anyway. So if I do this scatter plot, you can see it's a dinosaur, right? So this is kind of funny, like, okay, like that was kind of fun, like, cool. What's kind of interesting about this though, is that this is a very special data set. This is actually the Datasaurus Rex. And Datasaurus Rex is really interesting because it turns out there's some very specific summary statistics, just like you saw with this guy right here, okay, was very similar. You can actually create a whole bunch of different visuals with basically the same summary statistics. So this actually comes from a paper here, and they actually made a great animation here, is that you can see here, this is the X mean. So this is taking the average on the X axis, the Y axis, the standard deviation, and the correlation, basically how they're correlated. And you can see here is that as they're shifting these points, up to 2 decimal points, it's not changing, but you can see these little values are changing slightly, but you can very quickly look at this animation. Every single one of these data sets are very, very different from each other, right? Even though you can see here, and this is the power of visualization, is that visualization can give you a very quick summary of what it is. And as people, as humans, I say, like, we are very visually inclined. We notice these patterns very quickly. If you're curious, here's the paper a little about the Datasaurus dozen. And they show you a little bit. The original data set I showed you guys with, like, the linear relationship and then that parabola is actually, I can never pronounce his name right, Anscombe's quartet. Very famous. Basically, the whole idea here is that the standard deviation, the X mean, the Y mean are actually all the same from each other. And you can see that these are all very different data sets from each other. And then basically this paper from Autodesk blew this out of the water and said, all right, not only can they make huge amounts of different parts, but they actually showed a method of like actually modifying the numbers to make it basically the same summary statistics, these 5 values within like 2 decimal places, but still have some very different visualizations. So anyway, this is kind of like the motivation of like why visualization is so important. It's not just for pretty pictures. It's definitely for something that's a useful tool that you really should use and make sure that you have that to kind of export parts.